Okay, so let's take a look at number 6, which says a cheetah starts from rest. VI is 0. And accelerates through a velocity of 80 kilometers per hour. So VF is 80 kilometers per hour. South. In 2 seconds. Delta T is 2 seconds. And it wants to know, find the acceleration in meters per second squared, which means we need to change this to meters per second. So remember the rules. Meters will have to go on the top, kilometers on the bottom, 1 kilometer, 1,000 meters. Hours are going to have to go on the top, seconds on the bottom, 1 hour, 3,600 seconds. And when you do that, you should get, I think it's 22.2 repeating meters per second. And leave that repeating in your calculator, okay? Don't clear it, because we're going to use it in a minute. So we're going to use the equation A equals VF minus VI over delta T. So VF is the 22.2 repeating that you have in your calculator, minus 0, that should give you about 22.2 repeating, divided by 2 seconds. And when you do this, you should get 11.1 meters, and the 1's going to be repeating, meters per second squared. It's a vector, always in the same direction as the change in velocity, so south. For number 6. Number 7, a car accelerates at 10 kilometers per hour squared east from rest. So VI is 0. I guess we could do it in kilometers per hour, meters per second, 0, 0, whichever unit you put it in, and reaches a final velocity of 100 kilometers per hour, so VF, 100 kilometers per hour east. And it wants to know how much time has passed. Delta T is equal to question mark. So again, it's going to be A is equal to VF minus VI over delta T. And you want to rearrange for delta T, so divide both sides by the delta T. So A delta T is equal to VF minus VI. And you want the delta T alone, so divide by the A. So it'll cancel here. And now you can fill your numbers in. Now VI is 0, so lots of times when a whole term goes to 0, I will do this and just, rather than write it in, just indicate that it goes to 0. And so then what you're left with is 100 kilometers per hour. And they're both east, so you don't have to worry about positives, negatives. Divided by 10 kilometers per hour squared. So 100 divided by 10 is 10. And just up here, kilometers per hour divided by kilometers per hour squared. You're going to flip this one and multiply. So kilometers per hour times hours squared over kilometers. The kilometers are going to cancel. One of the hours is going to cancel, and you're going to be left with the other. So it's going to take him 10 hours. And that's one of the reasons why earlier I said we don't usually ever, this is the only question where you'll see the acceleration given in kilometers per hour squared. Because it's misleading. It sounds like a pretty decent acceleration, right? 10 kilometers per hour squared. Except you just found out it took this guy to go from 0 to 100 kilometers per hour, 10 hours. Talk about bad pickup in somebody's car. They definitely need to get it serviced. Okay? Number 8. If a plane accelerates at 25 meters per second squared east for a time of 15 seconds, delta T is 15 seconds, after initially going 40 kilometers per hour, that's your VI, east, find its final velocity in meters per second. So you need to change your 40 kilometers per hour east into meters per second. So what's it going to be, 11? Yeah, 11.1 repeating meters per second, okay? So A is equal to VF minus VI over delta T, and we're rearranging for VF. So to get the VF alone, multiply both sides by delta T. So A delta t is equal to Vf minus Vi, and now add Vi to both sides. So it'll disappear here. So it'll become Vf is equal to Vi plus A delta t. So now Vi is 11.1 repeating meters per second plus A, 25 meters per second squared, times 15 seconds. And everything is east, so again, you don't have to worry about negatives. When you do this, I think you get 386.1 meters per second. Works out to be positive, so it's east. And I gave you 4 sig figs in the question, so you keep 4 in the answer. B. All the givens in B are exactly the same, except the initial velocity is now west instead of east. So the VI is 40 kilometers per hour west, or in other words, 11.1 meters per second squared. And it's west this time, whereas up here it was east. So you're going to do exactly the same thing. A is equal to Vf minus Vi over delta t. Multiply both sides by delta t. Add the Vi to both sides, so you get Vf equals Vi plus A delta t. But now when you go to fill in, you have to worry about positives and negatives. And earlier we said we always consider west negative when the two of them are in a question together. And so the 11 is going to go in as negative 11 meters per second plus, sorry, I'm trying to get the page so my hand's not very steady. I was trying to extend the reach of the iPad. 25 meters per second squared times 15 seconds. Now I didn't do it up there, but 25 meters per second squared times 15 seconds will give you meters per second squared. So up here it would have been 11.1 repeating meters per second plus 375. Down here it's going to be negative 11.1 repeating meters per second plus 375 meters per second. So this time your VF is going to be 363.9, maybe 0.8. I think, repeating meters per second, and up here this one was repeating. And it works out to be positive, so east. One last one, number 9. Well, not really, but one last one that you had for homework. There's still more to do. Car traveling at 100 kilometers per hour, that's the VI. Accelerates to pass another car. It takes 6 seconds, delta t, to pass the car, and the velocity after passing is 140 kilometers per hour, VF. 1.40 times 10 to the 2 is 140. Okay, both of these you need to switch into meters per second because it asks for the acceleration in meters per second squared. So when you switch 100 kilometers per hour into meters per second, you get 38.8 repeating, I think. And when you switch 140, oh no, that's this one. This one's 38.8 repeating. And this one's 27. 27.7 repeating. Yeah. Meters per second. Okay, so A is equal to Vf minus Vi over delta t. So 38.8 repeating minus 27.7 repeating divided by 6 seconds. On the top you get, I think, 11.1 repeating divided by 6 seconds. And this should give you 1.85, maybe, meters per second squared. Because again, meters per second divided by seconds over 1 is equal to meters per second times 1 over seconds. So meters per second squared. Okay? Very good. Good news. There's more on the back for you to work on tonight.